Hello, in this video we'll be looking at a question from the A-level paper 1, more specifically paper 1-2 from the year 2023. This is the question we'll be looking at today, and I'll be doing the solution out on the whiteboard, hopefully just like your teacher would if you were in school. If you were looking for another question from this paper, you should be able to find that in a playlist below the video. Okay, let's get to this question. In question 7, we're going to be dealing with a lot of trigonometric equations, which means I'm going to be saying cosine and sine quite a lot. There's lots of long multiplied out equations. Bit of advice, put it on fast forward, skip ahead if you need, otherwise it might get a little bit boring listening to me droning cosine, sine. Skip the parts you need, rewatch the parts you don't understand. With that said, there are some really difficult parts in this, so there might be more of you watching because of that. The question A, part 1, starts off with basically solve this equation. Cosine plus sine squared equals 1. And they give you a clue, they tell you to expand this part out first. So let's go ahead and do that. Let's expand out the left hand side. We'll get cosine squared theta plus 2 times these two. Plus sine squared. Let me just write the sine squared first, so we get them both together. So that's this multiplied by itself, this multiplied by itself, and then cosine times sine, and there's 2 of them, sine times cosine, so there's 2 of them, and all this equals 1. Now this part here, the most fundamental thing in trigonometry really is that this squared plus this squared equals 1. That's part of the definition of it. So we get 1 plus 2 times cosine theta times sine theta equals 1. Let's take 1 from both sides. We get 2 times cosine theta sine theta equals 0. Divide both sides by 2, and 0 divided by 2 is still 0. So we have 2 possible answers. One answer is cosine theta equals 0, or sine theta equals 0. I always like to draw my sine and cosine. This is all the way up to theta, and cosine, let's see, goes like this all the way. Sorry, I said theta. Pi, I mean. This is sine, and this is cosine. Okay, so when is cosine theta equal 0? A calculator does this, obviously. But when is that equal to 0? It's at pi over 2. That's one answer. Theta equals pi over 2. When is sine equal to 0? At 0 and at pi. Again, a calculator will give you this one, and you have to draw a picture or figure something out to get to this one. Again, a picture is very useful. Theta is equal to 0 or pi. They're your 3 answers. 0, pi over 2, and pi. That's your answer for part A. Or I should say A part 1. Because A part 2, and this is actually a really tricky question. I'm just seeing if I have enough room here. Because there's a lot I want to say about this question. So part 2, it says verify that the only solutions to, not this equation, let me write it over here. The only solutions to this equation, cosine theta plus sine theta equals 1, is 0, theta equals 0, and pi over 2. Okay, it does tell you hence verify. Hence means look at the previous question. Previous question we got 0, pi over 2, and pi. Here they're telling us the only answers are 0 and pi over 2. And these questions look very similar. This squared equals 1, this equals 1. It's just that if we square both sides, we get to this. These are very similar questions. Now, what the examiner does not want you to do is to try and solve this. In fact, I don't know how to solve this. I would have to look it up. I'm sure there is a really clever way to solve it. If I wanted to solve this, I would probably try and draw a picture of them added together. Because here's sine and here's cosine, and just add them together. And I can roughly do that. Let's put in some numbers here. That's 1, and that's 1 up here. 1 plus 0 would get me a 1. And this is slowly going down, and this is going up very fast. So it should go up a bit. And then at pi over 2, that's 1 and that's 0. So it should come back to 1 again at pi over 2. And then this is going down and this is going down. So it'll stay going down. And let's see, this gets all the way to 0 and that gets all the way to minus 1. Minus 1. So it gets down to here, and let's see, this stops going down and this is still going down. So this is still going down. It looks something like that. So to solve this, when is this equal to 1? There's two answers. There's only two answers. Just like they've given it to us here. Sorry, this is not necessarily what you should do in the exam. I'm just trying to explain this part because it's a really difficult question. I'm guessing most students had a bit of trouble with this. So bear with me for a few minutes. I'm just trying to explain what I'm going to say in another moment or two. So this is not something that's really easy to solve. But what we're going to say is that we can just take the answer from the previous part, check all three of these and see which two work. That's all the examiner really wants. I'm just going to try and show you a little bit why. Here is cosine plus sine added together. So if we square both sides, all that happens here is 1 gets squared to 1, 1 gets squared to 1, 1 point, I'm not sure, 1.5 let's say, gets squared to a little bit bigger. 0 gets squared to 0. But down here, here's the interesting part. These guys, when you square a minus, they become a positive. So the squared answer, let me grab another colour pen and let's see, clean this off here. If we square 1, we get 1, we get 1, we get 0. This will go a little bigger. This will go a little smaller, and the minus will become a positive. So that's how we got three answers for it being squared. 1, 2, 3. But we're going to get less answers when it's not squared. So I just wanted to try and explain that a little bit. I guess another sort of way to explain it would be, let's take a really simple example. X plus 2 squared equals, let's go with 16. So what makes 16 when it's squared? 4. So, or minus 4. So what's inside here has to be 4 or minus 4. So you can probably just see the answer is either x is equal to 2 or x is equal to minus 6. There's two answers. But if I were to write this again down here as x plus 2 equals 4, the square root of both sides, just like here, the square root of both sides, there's only one answer, x equals 2. So not all of the answers for the squared part work in the non-squared part, but importantly, all of these answers are in this. I hope some of that made some sense. All that is to mean that the answers to this question have to be some of these, but not all of them. So we simply check. So what the examiner wants to see is they want you to write this again, cosine, and check some of the answers. 0 plus sine 0 is equal to 1 plus 0 equal to 1. Correct. 0 is an answer. And they want you to do this 3 times. Cosine pi over 2 plus sine pi over 2. Let's see, cosine pi over 2 is 0. Sine pi over 2 is 1. They add together to get 1. Correct. Theta is pi over 2. And one last time, cosine pi plus sine pi is equal, sine pi is 0. Cosine pi is minus 1, equals minus 1. Not correct. So it's not the solution. That's what they wanted. That's all they wanted for this question. They didn't need you to waffle on like I did over here. None of that was needed. This is all they wanted. I just had to show you some understanding of where it came from. And I don't think I did that good, but I know a lot of students out there are probably a little confused with this question. I hope that helped a small amount. Please ask some questions in the comments and I'll do my best to clarify anything. Okay, let me clean this off and we'll go on to part B. Okay, for part B, they ask us one of these questions. I'm sure it's a favorite of everyone. Prove this identity. Now, this is the question I warned you about at the start, that I'm going to be saying cosine and sine a lot. This is long, it's going to take up my entire board. My arm and my voice is going to be ruined by the end of this, but it's actually not that difficult of a question, although it does look very scary. So to prove an identity, I always just say, take one side and make it look like the other. Hopefully it's usually quite clear which side to take. I do usually say take the bigger, more complicated side. I'm not sure which that would be. This looks complicated. This is a bit bigger though. But the clear answer here is to take the left side. There's a fraction, two fractions. We can add them together and hopefully make it look like this side. So let's just start with that. Let's just add these two fractions together. Hopefully you all know how to add fractions. We look for a common divisor, and if we don't see one, we just multiply the two bottoms together. That'll be our common divider. So sine, the only thing he's missing from this common one is this side. So basically we multiply there by there, there by there, and we put them over, these two multiplied together. Okay, if you're unsure how to add fractions like this, you go back and check that over. I won't go into it too much depth here. So I'm just going to multiply sine times this, cross multiply. So I will get sine theta cosine theta minus sine squared theta, plus, now multiplying this bottom by this top, cosine theta plus sine theta minus cosine squared theta minus cosine theta sine theta. And all of this will be over these two multiplies. Now thankfully these are conjugates of each other. So we get cosine times cosine is cosine squared theta. Sine times sine is minus sine squared theta. Then we'll get cosine times sine, which is minus that, plus sine times cosine, which they're just opposite, they cancel. That's all we're left on the bottom. Okay, not looking too good. It's not looking like we want it yet. Let's see what we can do. Here's some common terms. Cosine sine cancels with sine cosine. Let's see what else. We have cosine squared and sine squared. They add together to get 1, or take away together to get minus 1. So let's use that one. So I'll rewrite this term here, or these two terms, sorry. Cosine theta plus sine theta minus 1 on the top, and cosine squared theta minus sine squared theta on the bottom. Okay, we're already finished on the top. We have it looking as we want it. The bottom is just one line away. We can go to our formulas. There is a line saying this is equal to that, and we're done. But it should be, you should be able to do this yourself, because it's just cosine squared theta plus sine squared theta equals 1. That's should be something on top of your mind. We've already used it twice in this. Well, that means so we want sines. We want to get rid of the cosine. So cosine squared theta equals 1 minus sine. We just fill that in. We get a 1, and we get 2 of these sine squares, which is what we were looking for. And what's the top? Cosine theta plus sine theta minus 1. Okay, that's it. We are finished. And I've mostly kept my voice. Just go slow on these. Students make mistakes on these questions all the time because they're so big and messy and hard to keep track of. But there's nothing too difficult. If you replace all these with just simple numbers, a half and 3/4, everyone will be able to do these. So just practice. Practice makes perfect on these ones. Okay, for part C, they have brought it all together. they want us to solve this equation equals this. This is from part B, I've left up here on the board, and this was from part A. So the first thing we should hopefully clearly do is replace this side with this one here. Basically use our answer from part B. So let me go ahead and put that in. I'm going to run out of room here, I'd say. Cosine theta plus sine theta minus 1 over 1 minus 2 times sine squared theta is equal 2 times cosine theta plus sine theta minus 1. Now, very conveniently, this number and this number are the same. So it's very tempting just to cancel both sides. But what I always say to students is, you can't divide by 0. So many teachers say that. You can't divide by 0. Well, I'm about to divide by these two terms. And they are in fact, from part A, we do know they are sometimes 0. So a better thing to say would be, if you divide by a term that can be 0, be careful. So that's where we're going to be here. You might want to even write to the examiner at this point, I know this sometimes equals 0, but I will deal with that later. So for the answer from part 1 was theta is equal 0 and pi over 2. When this happens, this guy is 0. This guy is 0. So let's just ignore these 2 points for the moment. We'll solve the question, we'll get some answers, and then later we'll look at these 2 points and see what the answer is there. Okay, I hope that's clear. So what I'm going to do now is I'm going to divide both sides by that, and that'll leave a 1 over here. Multiply both sides by this. So we're left with 1 is equal 2. This multiplied by here is 2 minus 4 sine squared theta. Clean this up, move that over, minus 1, divide by minus 4. We get sine squared theta is equal 1 over 4. Solving that, we get sine theta is equal plus or minus a half. Solving that, I always like to draw a picture to solve. Here is a sine between 0 and pi. So when is sine theta equal to plus or minus a half? This is 1. So here's a half. There's 2 answers here for a half, and there's no answers for minus a half. Between these 2 points, it never equals minus a half. So the 2 answers, we can put them on a calculator. We will get theta is equal 30 degrees. Are we in? Yeah, we're in radians in this. So 30 degrees is pi over 6. The calculator will tell us pi over 6. We need to figure out the second one. So if it's pi over 6 gap, should be pi over 6 gap. So the next answer should be 5 over 6 pi. And yeah, that's our 2 answers here. But we will lose marks if this is all we give. We do need to remember the 2 things we ignored when they were 0. So we need to go back here and fill in theta equals 0. And let's test that out here. We get 0. Cosine 0 is 1. This sine 0 is 0. 1 plus 0 minus 1, that's 0. That's 0. 0 times 2 is 0. 0 divided by anything is 0. 0 equals 0. Perfect. Theta equals 0 works. You'd want to show the examiner that, or at least write in English. Yeah, put in, I guess what you should probably do would be put in cosine 0 plus sine 0 and so on. Just to show them that theta equals 0 is an answer. I'll write it in over here. Is an answer. Or you could write that in English. You could just say 0 goes in, gets 0 equals 0. Same with pi over 2. Pi over 2, that gets a 1. That gets 0. Sorry, this gets 1. That gets 0. That gets, overall, that gets 0. That gets 0. Let me do this one different. At theta equals pi over 2, we get 0 equals 0. Therefore, theta equals pi over 2 is a solution. So something like that. So there's your 5 solutions. I'll add that in over here, pi over 2. Sorry, 4 solutions. Let me check that is how many the answer has. Yeah, 4 solutions there. Okay, I hope that was clear. Clear as mud, I'm guessing, near the end. It is a difficult question. It was the hardest question in this paper so far, definitely. And personally, I think it was a good question. It was very interesting. Not many students would have got 100% in it. So I hope I was able to help a bit. If you have any follow-up questions, please put them below. I'll do my best to try and answer as best I can. Until next time, have a great day.